Hello. Today we are going to talk about finding mixed derivatives. So this is problem number 53 from page A19 of Thomas's calculus book, 13th edition, early Transcendentals. And what this problem is doing is it's giving us a function w, which is a function of x and y, as we can see. And it wants us to verify that wxy equals wyx. And what this is saying here, we're just going to break down that notation, is this is saying the second derivative of w with respect to x and then y, so this is a mixed derivative. That x comes first down here, and then that y comes over here. And we're going to verify that this equals d squared w over dy dx. So these are both mixed derivatives, and when you have a function of two variables, you're going to have both of these as your mixed derivative. Essentially, it's only one mixed derivative because we're going to prove that they're equal. So we know that they're equal, we're just verifying it in this problem. Okay, so we're just going to break down one more thing. This piece is going to equal d dx of dw dy. That's where the d squared comes from, and the dx dy is on the bottom. And then, oops, I just realized I made a mistake. This is going to be an x. There we go. Okay, so that's what it's supposed to be, because they have that y on the x. Okay, then this is going to be d squared. Oh, made another mistake. Okay, this is going to be dy of dw dx. Okay, I'm just going to make this d a little bit clearer. Okay, sorry for all those mistakes there. Okay, so essentially we're proving this, which is what the problem is asking us to do, and I'm just breaking down the notation further so we can actually make it easier for ourselves to find the answer. Okay, so the first thing we're going to do, let's worry about this piece. So I'm going to do that in blue. So we want d dx of dw dy. Now, let's find dw dy. So first I'm just going to put that d dx there. Okay, our dw dy. So we're taking the derivative of w, which is a multivariable function of two variables, x and y, and we're taking the derivative with respect to y. So what that's saying is, remember, that x is going to be considered constant. So let's go by each term here. So x is considered constant in this first term. If we're taking the derivative of this with respect to y, that x is just going to be left out here. And then the derivative of y squared with respect to y is just going to be 2y. That's just like we normally do it. Okay, next term. X squared. That's considered a constant. So we're going to put that out here. Derivative of y squared with respect to y is going to be 2y. Similarly in this one, x cubed is considered a constant, and the derivative of y to the fourth with respect to y is going to be not 4x, it's going to be 4y cubed. 4y cubed, okay. So this is going to be d dx of 2xy plus 2x squared y plus 4x cubed y cubed. Okay, now the second part of this is we're just taking the derivative with respect to x of this new term that we found here. Okay, so let's do that. So now when we're taking the derivative with respect to x, all y's are considered constants. So I don't really need that there. Okay, so x, the 2y is going to be considered the constants here, and then we're taking the derivative of x, so it's going to be 2y, those are our constants, times 1, because the derivative of x is, with respect to x is just 1. Okay, in the second part, 2 and y are considered our constants, and then the derivative of x squared with respect to x is going to be 2x. Oops. And finally with this term, 4 and y cubed are going to be considered our constants. And now we're taking the derivative of x cubed with respect to x, and that's going to be 3x x squared. So to simplify this, this is going to be 2y plus 4xy plus 12, let's put x first, x squared y cubed. Okay, so this is what we want it to equal to. Alright, and this right here, remember, this is d dx of dw dy. That's the same thing as w of xy. I'm just going to put that in parentheses here. Okay, so this is the exact same thing as this, right? That's not a division sign, so I'm going to get rid of that. And I'm actually going to put a little squiggly there. And I'll put a squiggly here. Okay. So that's the first part. That's the first part that we're verifying. The second part is we want this expression right here to equal w of yx. Alright, so let's do that. And remember, we said that's a d dy of dw dx. So we're going to write that out. Okay, so now we're going to follow the similar process as we did up here. Just now we're taking the derivative of this with respect to x. So we have that d dy. Okay. So with respect to x, y is going to be considered a constant. So in here, our y squared is going to be considered a constant. And then the derivative of x with respect to x is going to be 1. Okay, to the second term. Y squared is going to be considered our constant. And the derivative of x squared with respect to x is going to be 2x. On to our final term. So y to the fourth is going to be considered constant because we're taking the derivative with respect to x of w. So we have y to the fourth here. And then finally, our derivative of x cubed with respect to x is going to be 3x squared. So to simplify this a little bit, we're going to have d dy. This is going to be y squared plus 2x y squared plus 3x squared y to the fourth. Okay, and now we're taking the derivative of this expression right here with respect to y. So when we're doing with respect to y, just like before, x's are considered constants. So we're going to go term by term again. So there are no x's here to be considered constants. So I mean, our 1 is just a constant, but we don't normally have to write 1. So the derivative of y squared with respect to y is just going to be 2y. Okay, next term. Our 2x here, that's considered, those are your constants. So we're going to put 2x out first. And then the derivative of y squared with respect to y is going to be 2y. And then finally, onto our last term, our 3x squared is considered constant because we're taking the derivative with respect to y. So we're going to put that out first. And then the derivative of y to the fourth with respect to y is going to be 4y cubed. Okay, simplifying this a little bit, we're going to have this 2y. Our second term is going to be 4xy. And then our final term is going to be 12x squared y cubed. And that's going to be w of yx. So now, we can see we have the 2y and 2y. We have the 4xy and the 4xy. We have the 12x squared y cubed and the 12x squared y cubed. And this is just verifying that this right here is equal to this right here. So that's what we're verifying. We want to verify that the mixed derivative with respect to x and then y first is the same thing as the mixed derivative with respect to y and then x. It's the exact same value. So when it's asking you to find, so in our last video, when we were taking second order partial derivatives of a function of two variables, let's say we had f of x and y, and it told us to find all second order. We have, using this notation up here, we have f sub xx, f sub yy, which is just saying the second order derivative with respect to x only, the second derivative of f with respect to y only, and then we have f of x sub y And that's the same thing as f sub yx. So essentially you only have 3 second order partial derivatives, one of them being the mixed derivative, and since it's only a function of 2 variables, it's just going to have one mixed derivative, and these are going to be the same. So I hope that helped, and we'll see you next time.